for a member B to C, this will be no translation for this horizontal member. But if you compare the column A to B, there will be translation for A to B. And as well as there is one presence of theta B is there. Okay, because of the translation from B to B dash, so this delta, whether this delta is going to contribute in this theta or not, that we have to analyze. And for that purpose, we have to establish the relation, we will establish the stiffness matrix. Okay, now how this stiffness matrix will come into the picture? If at all we are looking to this frame, so delta is one of the unknown parameter. One parameter unknown is theta B, another parameter is theta C. Let us say that we assume that theta B is equal to 1 as, or we'll say that this D1, this will be as a D2, and let us say the delta is our D3 is there. So we'll have a matrix of 3 by 3. Stiffness matrix will be of 3 by 3. Okay. Now, how this matrix will be developed? This matrix will be developed by considering, first we have to consider theta B is equal to 1. When you consider theta B is equal to 1, at that time its effect on the another theta C, okay, this will give you S21. Its effect on the delta will give you S31. Okay. Now, what will be the effect of this in the delta? So see that theta B is equal to 1 means that if you consider the rotation, for now particularly we will consider only for this member. Okay, if you draw a FBD for that member, see that there is column. Now this column will like A2, A and B is there, and another member is this B2, C is there. And if you remember that what we have drawn yesterday, if we have to consider theta B is equal to 1, okay. So I will need anti-clockwise rotation. So this will be one shape we here and another shape will be here. Okay. Now for that also suppose you apply 4EI by L moment over here. Okay. And that moment 4EI by L moment is for, this will be for BC. And again for this also we will apply 4EI by L moment. And this another moment in the same direction will be 2EI by L. And we know that if at the time of the development of this, we have also developed that there will be one reaction when we consider unipositive rotation, its reaction will be in the upward, one reaction will be in downward, and these reactions are 6EI by L square, and this is also 6EI by L square. Now here whatever the force is there, this is 6EI by L square, this is going to contribute in the delta, this is going to add in the delta. Okay, these things we have to consider while there is translation in the frame is there. So this is a change. What we initially we have seen the non-sway means that there is no translation, delta is always equal to 0. So we only bother about the rotations theta. We are going only, we have analyzed any structure which is based on the unknown parameters is the theta parameters are there. At the structure where the rotations are only unknowns are there, that we analyzed in the non-sway category. Sway category will come into this picture. Okay, in this way we have to handle this way. Okay, but one more thing is that while we have calculating this, we have to know that we have find out the ADL1, that is a displacement at the joint because of external loading. Let us say that for ADL1 for theta B, according to our diagram, we can say that MFB to A plus MFB to C will be there. Suppose ADL2 is equal to, now you can see that MF C to D. But now here ADL3 will be what? So see that now here third is our what we have assumed this delta. So can anybody will guess that delta? What will be the now delta here in this case ADL3? Can anybody? You can guess at least. Because this is related to theta, this is related to theta. Okay, at that time you have considered this moment. Okay, rotations are because of moment, rotations are because of moment, and this delta are because of the forces. This is not because of moment. Now can you contribute in this? Can you, okay, if you not understood this,
Sir,
okay,
force
then
B.
yeah, correct. Force. First thing is that if you look to the frame now here, I can take directly numerical also, but I want that your concept should be clear so that even though one problem is enough for the understanding of the entire topic. That's why I am discussing this. Otherwise, directly numerical we can take from that what you understood, that is not important, okay? But here important is that what you understand from this is the important, or that should be the aspect. That is my aim. See that here when the structure is subjected to some horizontal load, okay, here 50 kilonewton load will be there. When this will deflect, when the opposite reactions are not equal, are less than or greater than this 50 kilonewton load, then and then it is possible to have this as a sway. Otherwise, what will happen? Suppose 150 kilonewton load is over here, and here this 50 kilonewton reaction is from these both these structures. Suppose here it is 50 kilonewton, it is offering from this. So what will happen because of this? There will be no sway in a frame, but this will be not the case in the structures. So here always while we look into this, first thing is that we have to find out here ADL3 is unequilibrium force. The force, the force, the force which will cause a sway. Okay. How we can find out now this? It's simply we have to draw a video of this free body diagram of the structure. Okay. Now you show here 50 kilonewton load. Here, if loads are there, you show over here. Otherwise, you find out the reactions of this. Only you have to find out the reaction. Considering that this has a statically determinate one, you have to consider like this and find out the reaction. Let us say that here one reaction is 20 kilonewton and this is a 30 kilonewton. What will happen here? This 20 kilonewton will be transferred to this, and this will be transferred to opposite to this, and this will be like this, and then again this. Okay, if and suppose here one more load is acting over here, okay, and this reaction is suppose 5 kilonewton, this is 5 kilonewton, now this is a 20 kilonewton. So addition of these two, now in this beam B to C you apply summation fx is equal to 0. Here when we apply summation fx is equal to 0, 20 minus 5 is equal to 15 kilonewton. This is the force, that is a 15 kilonewton is an unequilibrium force which will be causing sway in a frame, which will be causing sway in a frame. So likewise, while we calculate ADL1 and ADL2, this is unbalanced moment. After calculating or after determining by using standard formula MFAB plus MFBA, this is ADL1 and ADL2. Similarly, while we have to deal with the structure which is subjected to sway, at that time you have to consider that structure is statically determinate and find out the horizontal reactions or the reaction at columns, and the difference of these two reaction is your ADL, or that is an unequilibrium force, that is a force which will be causing a sway in a structure. So we have to look into that aspect for that this type of structures. Okay. Now here this as you after getting the L1 after this, so you know that the process first we have to consider theta b is equal to 1, then theta c is equal to 1, and later on we have to consider delta is to be 1. When you consider delta is to 1, its effect on theta b, its effect on theta c, that you have to study. When you consider theta b is equal to 1, its effect on this theta c, its effect on delta, that will be your stiffness matrix for 1 1. When you consider theta c is equal to 1, its effect on delta and its effect on theta b is your another stiffness matrix. So this will, in this way or in this approach, we have to develop the stiffness matrix. We'll see the one numerical in detailed manner, and if you are in a doubt meanwhile in that, you ask without any hesitation, so that your all concept related to the stiffness matrix should be get cleared. Okay, so write down. analyze the frame as shown in figure. So I will take this some complicated or some different difficult frame where will be all types of loadings will be there. So you will be having minimum problem for understanding. Let's say this. Okay, let us say that this is a 4 meter. This distance is the 3 meter is there, and one load acting over this frame is of 40 kilonewton, which is at 1 meter from this. This distance is 2 meter. Notations are A, B, C, and this is D. Over this there is a UDL. Actually, this is not the possible, but as it is been given, so we have to consider this 25 kilonewton per meter. And on the slab there is, this is one of the member which has the 50 kilonewton load at the center. This is 1.5 meter, this is 1.5 meter. So this is the ABCD frame is there. Okay. So this frame we are going to analyze by using stiffness metric method. This is very easy. Don't look to the according to the loading. If you think that is difficult, then it is not possible for you to analyze. You have to divide the structure in the subsequent part. What are the process are there? What is the process for analyzing? What is the first step? If you go by stepwise, then it will be very easy for you to analyze this type of structures. Okay, so that every problem has some smaller step. If we divide bigger problem in smaller targets, so then this will be easily we can analyze any structure over there. Okay, let us say first step is to find out the degree of kinematic indeterminacy. So as we have discussed lot many things, you can easily understand that degree of kinematic indeterminacy in this case will be 3. Okay, one will be theta b,
Theta
okay,
C.
theta c, and delta. Okay, only okay, there may be possibility that you may assume since the delta b is equal to delta c is equal to delta, that we have to assume. Okay, why we do this? Actually, first thing is that there should be delta b, delta c is correct. Okay, but what we assume that delta b is equal to delta c. Otherwise, what will happen if the delta b and delta c are not equal? Then there will be 4 unknowns in a problem, and in at all that 4 degrees of unknown, we have to analyze this by mathematical equation. It is not possible. So we always, whatever the structure we are analyzing, what we simplify the structure in smaller steps. So considering that, we have considered delta b, delta c is equal to delta, and this is, and delta towards right is considered as a positive, and we are going to consider delta towards right. So while drawing a diagram, I will consider only delta towards right side is a positive, and that I will going to consider in this case. Okay, now this is the way here. So second step is we have to assign the coordinates to this. Assign the coordinates. So assign the coordinates means that let we'll assume like d1 is equal to theta b like yesterday, d2 is equal to theta c, and d3 is equal to delta e. D3 is equal to delta. Okay. Now third step is, you know, that to find out the fixed time moments. So we can find out MFAB is equal to minus MFB to A is WL square by 12 for fixed time. So this is W is a 25 4 square divided by 12. This is equal to this. Then MFB to A, MFB to C is equal to minus MFC to B is WL by 8. So we'll have this first is W is equal to 50 into 3 divided by 8 is equal to this. And later on, the for next span MFCD is equal to WAB square. So W is 40 into A is 2 into 1 square divided by 3 square is equal to this. then MFD to C is equal to minus 40 into 2 square into 1 divided by 3 square is equal to this. So all of you please give me the moment values. If you calculate this will be very good.
33.33 kilonewton
Okay,
meter.
33.33. This is kilonewton meter.
18.75.
18.75. This is also kilonewton meter.
8.89 kilonewton meter.
8.89 kilonewton meter. Other people, please check this answer whether it is correct or wrong. We get some difference.
17.78.
Yes, correct. 17.78. Okay,
78.
17.78. This is minus kilonewton meter. Okay. Now we have to find out the ADL1, ADL2, and this then we will be having some ADL3 we have to determine actually. Okay, I will draw the first free body diagram for this. I will mark here only first is ADL1 and ADL2. This things we will mark here. Okay. This is the moments. That one, these are this ADL1. ADL1 is this. ADL2 is this. So this is at C. This is at B is there. For ADL3, I can draw a separate one more diagram. Here we can show, but this will again create some confusion to you also. Okay, let us say that here some load is acting over here. In that circle, one reaction is there. Similarly, one load is acting over here. This is the reaction, and this will be transferred to this. This will be transferred to this. And if at all we have to mark this, so this is nothing but the and this is nothing but our ADL3. So difference of these two forces. Okay, this we have to calculate. Likewise this. So we'll work out one by one. Okay. First is the we have to this find out ADL1 is equal to. So we'll know that this is the MF B to A plus MF B to C is equal to 0. So this is minus 33.33 plus 18.75. This is equal to this. ADL2 is equal to MF B to C is K plus MF CB CD. CB plus MF C to D is equal to 0. So this value is equal to minus 8.89, sorry, minus 18.87, minus 18.75 plus 8.89. This is equal to this. EDL3 is equal to, for that EDL3, draw a different diagram showing columns. First thing is this. Okay, on this column, one load is of 40 kilonewton, which is acting over here. This is 1 meter, this is 2 meter. Okay, over this span there is a UDL. Okay, this is a 25 kilonewton and this is 4 meter. So what we have to find out is here, what is the reaction at this location and what is the reaction of this location. This is we have to find out actually. Rest of the forces we don't need. Rest of the forces we don't need. We need only these two forces. Whatever the reactions are there, this will be transferred to this only in BC. Remember, B to C is there. Okay. So can you find out this? Here this is B, this is C is there. Okay. So what will be this RB here? In that case, what we can do? Here we take moment at E is equal to 0 directly. Let us say that minus RB minus HB, we'll write down here is HB and this is the HC is there. HB into 4 plus 25 into 4 square by 2 is equal to 0. So this will give you HB is equal to how much? In the similar this case, moment at D is equal to 0. So this is minus HC into 3 minus 40 into 1. Okay, 40 into 1 is equal to 0. This is the thing is there. Suppose then HC is equal to, we have to calculate this. Okay, can you calculate now what is HB? Anybody has got the answer
Yes,
for this?
50
HB is
kilonewton.
equal to
50.
HB is equal to 50. Okay, good. HB is equal to 50 kilonewton. HC is
HC
equal to
13.33.
SC is equal to 13.33 kilonewton. Okay, 13.33. Now this will be 13.33 over here, and this will be 50, which is acting over here like this. Okay, these are the similarly that we have transferred to this. Okay, now here we can apply the directions of this frame. Okay, first you got this reactions, so we have to find out now EDL3 is there. So EDL3 in this case, okay, looking,
36.67.
okay, how much?
36.67.
Okay, ADL3 is equal to, see that this is in the direction. Now we, this is opposite direction, suppose we considered negative at this HB. Okay, and this force we considered as a positive. So this will be minus 50. We'll have this, and this HC is in a plus, so plus 13.33. This direction we have to look into the columns, not do not consider on this beam or this. Okay, minus 15 plus 13.33.
Minus 36.67.
Minus 36.67, and this is in kilonewton. So ADL1 to ADL1, ADL2 and ADL3 we got this. So in this way you can find out the ADL3. For this ADL3 you have to draw this way. Okay, in this case this is nothing but summation f is equal to 0. I don't write this actually. ADL3 here, one more thing I will write down here. ADL3 is equal to minus HB, or say that HB plus HC is your ADL3, and here this force was positive, this force are negative at column for your more confusion. Okay. This is the ADL1 and ADL2, ADL3 is there. Okay, later on next step is, we know that we have to find out the stiffness matrix. Okay, stiffness matrix will have three cases. Okay, First, for let us say that theta b is equal to 1. For that, we have to draw a diagram. Again, I will draw the diagram for this. So A is B, C, and D. For column, your diagram will be like this. Theta b to 1. For beam, the diagram will be like this. If we agreed on this, so we can look this. Okay. And here we can have a tangent in both the directions. Here theta b is equal to 1 is there. Theta b is equal to 1 there. So whatever the moment will be here, this will be your S1 1. Okay. Another moment which will be acting over here will be S2 1. And it effects on the translation will be S3 1 is there. Okay. Instead of showing at that joint also, you can show here also. Yes, 3 1. For because this is for only this vertical column. For that the reaction will be there for third one. Okay, this is for theta b. Okay, so can you write down for first? We'll complete case one by one. Okay, when theta b is equal to 1 at that time, yes, 1 1 is equal to, please check this, 4ei by l. Then this is for first is b to a plus 4ei by l, that is for b to c. This is your this. Yes, 2 1 is equal to 2ei by l, but that is for span b to c is there. And then yes, 3 1 is equal to 6ei upon l square, but this is for height, column height, that is ab. Okay, now you can put the values here. 4ei by l is 4 plus 4ei by 3. Okay, this you can have, this is 2ei by 3 is there, 6ei divided by the 4 square is there, 4 square is there. So can you tell me the answers?
S11 equals to 2.33 EI.
Yes, 1 1 is equal to 2.33 ei.
S21 equals to
Yes, 2 1.
0.66 EI.
Hmm. Yes, 2
0.66
1 is
EI.
equal to 0.66 EI. Okay, 0.66 EI. You can
S31
have
equals
0.67 if this,
to
just to make this correction, because later on again answers will be some difference are there. 7 upon EI. Okay, and this is
0.375 EI.
0.375 EI. All people are getting these answers. Yes. Can anybody one will going to reply?
Yes, sir, same.
Okay. Yes, Dhanush. Thank you. Okay, now we have considered theta b. Next case will be there theta c is equal to 1. Okay. Now here when we say the theta c is equal to 1, second case will be there. Again we'll draw the frame. Now again if you draw a deflected shape for this will be again anti-clockwise rotation. So this will be in this manner. It will get deflected. For this, the deflection will be in this sense. So we'll have the tangent for this. So if you measure this, so theta b is equal to 1. Now the rotations over here will be s2 2. Its effect for this will be s1 2, and its effect on this second is s2 3. 3. S21 is equal to S12. This will remain same. This will be same again. S13 is equal. C is equal to 1. So let us say that for that this will be S22 is equal to 4EI by L. That is for first span is C to B plus 4EI by L. That is for span C to D. Here 4EI by 3 is there. Similarly in this span also 4EI by I by 3 is also there. So 4 divided by 3 plus 4 divided by 3. This will be equals to 2.67. Is it right? Check this. Then S32 is equal to S23 is equal to 2EI by L. 2EI by L. This is 2EI divided by L is 3. So this is again 0.67 EI. Okay. Later on, the third case will be where we have to consider delta to be 1. Understood up to theta B, theta C. Is there any problem up to this?
No, sir.
Okay, nice. See that what is the difference here in a theta C. So now next is we have to consider delta to be 1. And for that we have to draw a diagram for the both the columns so that there will be considered the delta at for both AB and also at C to D also there. We first draw the okay. This will be there. So deflected. Now here we have to consider delta to be 1 for this also. For the this is also there. We have to consider here delta. Here will be again delta is equal to this. Okay. Now to apply this force, whatever the force will apply in this is your S33. Its effect on this moment is S13. Its effect on this moment over here, that will be again, so S23 is there. That we already calculated and rest of the things are already known to us. So only S33 we have to work out. Now S33 we know that to have a delta is equal to 1 12 EI upon L cube. Okay, this moment is you know that this is 12 EI upon L cube. If we apply this much force, then the displacement will be 1 for this column. But that will be again for this. So we have to addition of these two. S33 will be S33 will be equal to 12 EI upon L cube. That is for one column, that is AB, plus 12 EI upon L cube for the second column, that is B. CD is there. So just you put the values 12 EI upon 4 cube plus 12 A upon 4 cube divided by 12 plus 12 A upon 3 cube. So addition of these two, you can calculate these two.
0.632.
0.632. Okay. Now all of you know that this is a in this case we have determined all the stiffness matrix and the rotation because of or displacement because of external loading. So we can use the Basic equation of stiffness matrix, AT is equal to ATL displacement here at D because of external loading plus stiffness matrix into the displacements. D is there. So we just write down this. So initially no loads or no moments which are acting at the D or the unknown parameters are there. So they will consider this as 0. ADL we have calculated for A1, 2, 3 for both the cases. Okay. Okay, how much was the first? Minus 33 from this. I have calculated this.
Minus 14.58.
Minus 14.58 minus 18.75 plus okay, yes, minus
86.
9.86 or 87, 14.58, 9.87 and 36.67. So just put these values. 14.58, this is minus 9.87 minus 36 point plus stiffness S is equal to S11 we have calculated. S11 is equal to here 2.33, 0.67, 0.67 and 0.325, right? 375, not 325, it is 375 upon outside of this bracket is EI. Write down another bracket over here. Now this is 0.67. This here plus 21 to 2.67 and this is 0.67. 0.375, 0.67, S33 is 0.632. This is EI into this theta B, theta C and delta. Solving this, we get theta B is equal to theta C is equal to and delta is equal to. Can you tell me what is the final answers?
Sir, theta B is minus 1.5 upon EI.
Theta B is minus 1.50 upon EI.
Theta C is minus 14.55 upon EI.
14.55 upon EI.
Delta is 74.19.
74.19 upon EI. Delta is positive means that the delta translation in the direction of force. Okay, in this way the direction will be there. These minus signs of rotation indicate that these rotations are in the clockwise sense. Okay, initially we have assumed that anti-clockwise is positive. We assume that all rotations are positive, but our answers are negative. It means that rotation will be in the opposite direction. Okay, just we get now this theta b, theta c, and delta. Rest of the thing is we have to apply slope deflection equation and find out the support reaction, and you can plot SFD and BMP. So this is the way the sway can be handled in the particularly when the structure has to be analyzed by stiffness matrix method. So you can imagine or you can understand that by if we compare the other methods that initially we have used for analysis of sway, considering this way in a structure, moment distribution method or slope deflection method, this is quite easier. Okay, this is the simplest method to analyze any structure which is subjected to the sway. That is the why the most popularly or mostly it is used, and even though we get a solution in the early stage of the any problem. So let us this is the structure that we have analyzed. Okay, hello, am I audible?
Yes, sir.
Okay. This is in a tutorial example. This will be the last example on the slope and deflection, and later on from the tomorrow we will going to start the uh, plastic analysis. And please remember that tomorrow there will be extra lecture, and Sunday there will be also lecture of essay. We will try to finish these topics in the Saturday Sunday, or probably if something remains that will take on a Monday. Okay. Then tutorial in that you have to take this example. These are the this is the frame actually that you have to analyze in the tutorial. Okay. Similar manner, this recording is on MS Team. You can use this for your reference. Okay. So this is the actually we have already completed the entire topic of varieties of problem that so far will come into the slope and deflection. This. So related to this, if at all in the objective exam, what will be the asked? Okay, first thing is that it will be asked to find out the degree of kinematic indeterminacy. Later on, that will be asked for you that to have a theta b is equal to 1, what will be its unit positive rotation, or what is the stiffness of B, 4EI by L, 2EI by L, or this. To have a unit positive rotation at this, or unit positive translation, what will be the stiffness? Okay, this unit positive rotation force will be 12 EI upon L cube. Rotational moments are 4 EI by L. Its effect will be on the farther end is 6 EI over 2 EI by L. When we apply in a couple or moment at B, its effect in the translation will be in terms of reaction is the 6 EI by L square. That actually that you have to remember everything in the with the relation. What is the relation to among these others? See that if you remember our very first lecture, if you understand that concept in the first lecture, that is more than enough for to solve any type of problem here in the stiffness matrix method. Okay, if at all sometimes what will happen, sometimes there are different varieties of questions will be there. one variety I would like to discuss with that. Sometimes beam will be subjected to the translations. Now, when will beam be subjected to translation? When beam will have the varying moment of inertia, in that case it will become difficult. Okay, let us say that there is one beam. Let us say that there is one beam which is fixed at both ends. Okay, but it has a varying moment of inertia. Let us say that this has a moment of inertia is 2I and this is I is there, suppose. Okay, so what will happen when there is varying cross section between one span? Remember that here is no support, here is no support in the one span. Whatever the span is there, suppose let us say that this is 3 meter span is there, but in that we use the two sections. One is having larger depth, another is having smaller depth. So because of this geometry, there is formation of internal hinge over here. This will be the formation of hinge here. And if at all you find out the degree of kinematic indeterminacy for this case, this will be 2. Okay, what will be the 2? Suppose let us have that. Suppose you assume that this as a B is there. Okay, 2 in that is in that case 2 means that there is theta B and there is presence of delta B also. This is the important that we have to look into this. Okay. And now when we say that this is theta B and is there, so what we have to do is we have to understand that what will be the happen here in one case in a stiffness matrix. If we apply this will be EDL1 will be there and EDL2 is also there. So what we have to do here first is you can in this type of structure what you can do is you can first you draw a FBD. So let us say that up to B is there with this and this is later on this. Okay, and if at all we have to find out this ADL1. So this ADL1 is nothing but because of moment. Okay, this is the thing but the because of movement, so we can have this is a movement over here. This is actually this is movement is because of this ADL, and now you find out the reaction in both the sides, suppose. Okay, depending on the direction of this depending on the direction of this here ADL1 will be calculated in this way and ADL2 is this. So later on when we say the theta B is equal to 1, similarly there will be again two spans. One is for this, here is suppose intermediate is there. So we'll have the one diagram will be towards this side. Okay, another will be towards this side. If we draw a tangent over this, so this will be like this. Okay, you will apply this, so this will be your S1. Its effect in the direction of this will be S2 1 will be there. Okay, and now here we have to look into this. Let us say that at this point if you draw a separate diagram, then you can understand this. Actually if we for B we have the deflected shape will be this, for the another span it will be like this. If we look to this, so there will be this will be in a downward sense and this will be in a upward sense. Even though these reactions are same 6 EI by L square, this is 6 EI by L square. But as this is anti-clockwise rotation, at that time this will be in downward, this will be in upward. Okay, so this will be the going to change the direction in the flow. That is S21 we have to calculate this. So one is plus, another is minus. So minus 6 EI by L square, this will be plus 6 EI by L square. The effect, net effect we have to consider while calculating the S21. It means that while you writing down this, it will be writing like 6 ci by minus 6 ci by L square for span B to A plus 6 ci by L square for span B to C is there. So likewise will be there. This will be the change in this type of problems. Okay. So maybe possible this type of questions will be asked in the objective exam for to check your concepts. Okay. And while we considering the now rotation to be 1, so again at that time you can draw two different diagrams. Here we can consider delta B is equal to 1. Similarly, for this also we can consider delta B is equal to 1. For both the cases, delta B is equal to 1. For that, we need to apply 12A upon L cube, 12A upon L cube for both the cases. So S22 we can directly write down here 12A upon L cube, that is for B to A plus 12A upon L cube is for B to C. So this is the way, and there will be no change in the moment. So this will be in the again anti-clockwise for this is also the sum of these two. This will be the effect of S12. This will be the effect of S12 like this. Okay. You can calculate in this way. Might be possible in this type of cases. You have to be careful while drawing the diagrams or while calculating this. And always remember that even though you apply this S12, whatever the S12 will get from that S21 and S12 both will be equal. Okay. Conceptually, we should understand this. So that's why we have to discuss this. Okay. So in this way, you can analyze any beam or frame this. If you have any doubt, you can ask. Otherwise, you can put the attendance in a chat box and you can leave the meeting.
सर
Yes.
सर काल जे एक्झाम्पल घेतलं ना फ्रेमचं त्याचे सपोर्ट रिॲक्शन
Support reaction का? Just a minute. Okay. What do you get for that support reaction for this? Just a minute. Tell you the support reaction that I have with me. 25 kilometer, 50 kilometer. Horizontal reaction at C, HC is equal to 25.60. Okay, I will go to that problem basically, then you will learn, we will discuss over there. This is today's problem. Okay. We have discussed over here. Here itself. Okay, whatever the reactions we got here at HC is equal to 25.60. You can check this. Vertical reaction at C is the 28.64 kilonewton. At this there, but this horizontal reaction 40. Vertical reaction here is 46.36. And moment I think already calculated this is 24.18. Is it right, Dhanashri?
येस
Okay, nice. Okay. So thank you. We'll see the next topic in the next lecture.